Metformin is a widely prescribed oral anti-diabetic medication, primarily used for the treatment of type 2 diabetes. Its mechanisms of action are multifaceted and not entirely understood, but current research highlights several key processes. Main actions: decreases hepatic glucose production. Metformin reduces the amount of glucose produced by the liver, chiefly through inhibition of hepatic gluconeogenesis. Improves insulin sensitivity. It increases insulin sensitivity and promotes peripheral glucose uptake, primarily in muscle tissue, helping tissues utilize glucose more efficiently. Decreases intestinal glucose absorption. Metformin modestly slows the absorption of glucose from the intestines, reducing postprandial glucose spikes. Molecular mechanisms: inhibition of mitochondrial complex 1. Metformin accumulates in liver cells via the organic cation transporter. It inhibits mitochondrial respiratory chain complex 1. This reduces ATP production, alters cellular energy ratios, and activates the energy sensor AMPK. Activation of AMPK. When AMPK is activated, it inhibits processes that consume energy and promotes catabolic activities that restore cellular energy balance. Inhibition of mitochondrial glycerol 3-phosphate dehydrogenase. At therapeutic doses, metformin inhibits GPD2, increasing cytosolic redox states. This reduces gluconeogenesis from substrates like glycerol and lactate, thus lowering glucose output from the liver. Lysosomal mechanism. At lower concentrations, metformin may also activate AMPK by a lysosome-dependent pathway involving lysosomal proteins, bypassing mitochondrial energy changes. Effects in the gut: changes in gut microbiota and GLP-1 secretion. Metformin alters gut microbiota and increases the secretion of glucagon-like peptide 1. This effect is mediated through specific gut receptors and proteins which are directly involved in stimulating GLP-1 secretion, enhancing insulin release. Additional properties: anti-inflammatory and immunomodulatory. Metformin shows anti-inflammatory properties acting through both AMPK-dependent and independent mechanisms. Key points: the liver and gut are primary target organs for metformin's actions. Clinically, metformin's dominant effect is to curb excessive glucose production from the liver. In summary, metformin lowers blood glucose mainly by inhibiting hepatic glucose production, with secondary benefits on peripheral glucose uptake and gut-mediated effects. Its complex, multi-targeted actions have made it the first-line drug for type 2 diabetes and a subject of ongoing research for other conditions. Share and subscribe for more such videos.